Let's recall that the solution of an nth order linear non-homogeneous ordinary differential equation has the following form and has two components or two solutions. Okay? The first set of solution is y of h, which we call the homogeneous solution when we set our ordinary differential equation to 0 and solve for the homogeneous solution. The solution to our linear non-homogeneous ODE will also have a second part called the particular solution. Also, let's recall that the solution to the homogeneous ODE will belong to either of the three cases as stated below. So, para ma-solve nato atong non-homogeneous linear ODE, kinanglan de gyapon nato pangitaon ang solution as if homogeneous siya. So, iset sa nato siya daan to 0, find y of h, that could be either of the three cases, and also solve for the y of p. So, how do we solve for the y of p? From the previous recorded video, I've mentioned na we could use one of the two methods. It could be either the method of undetermined coefficients or the method of variation of parameters. Now, for this module, we're going to only focus on the method of undetermined coefficients. The first condition for us to use the method of undetermined coefficients, or MUC, is when phi of x, which is equal to g of x over bn of x, diba, is only applicable when phi of x and all of its derivatives can be written in terms of the same finite set of linearly independent functions. If pwede siya masulat sa ingani nga form, then we could use MUC. For common functions, we could use either of the three cases. So, these three cases are different from sa itong before nga three cases. So, this is only applicable sa method of undetermined coefficients. Case 1, if our phi of x is a polynomial or an nth degree polynomial in x. So, our particular solution, y of p, could be of this form. Okay? Case 2, if our phi of x is an exponential function or an Euler function. Okay? Where k is a constant and alpha is the coefficient of the power of e. Okay? So, ang atong y of p would take this form. Second equation. Case 3 is if our phi of x is a sum of a sine and cosine function, where k1, k2, and beta are known constants. So, if ingana ang atong phi of x or atong homogeneous equation would be, non-homogeneous equation would be equal to that, our particular solution would be of this form. Kanang third equation sa atong slide. So, for all three types or all three cases of solutions, our a's and b and a sub i's are all constants and mo atong i-determine. Hence the name method of undetermined coefficients. What if our phi of x is not just a plain polynomial? Or dili lang siya plain nga Euler function? Or dili lang po siya plain nga sums of sine and cosine? What if phi of x is a product of terms considered before or above? Then yp, our particular solution, is also a product of the assumed solutions. So, for example, when phi of x is a product of the Euler function and polynomial, ang particular solution would also be a product of the Euler function and the solution for the polynomial na phi of x. So, the same gyapon, if our phi of x is a product of three sets of predefined functions, phi of x is equal to an Euler function times a polynomial function times a sine function or whether cosine function, ang iyahang particular solution would also be a product of those assumed solutions. For whatever constants ang mo gawas, we could algebraically combine them if possible. So those are if products. What if sum and difference? So the same na gyapon, no? If phi of x is a sum or difference of terms considered above, if it is a sum of polynomial function and sine function, then yp is also the sum of the assumed solutions for the polynomial function and the sine function. And if possible, we could also combine the constants. Di ba when solving for the non-homogeneous linear ODE, ato first isolve ang ODE what if homogeneous siya. So we have first obtained the YH. If any term of the assumed solution is also a term of that y of h, then the assumed solution must be modified by multiplying it by x of m. Okay? So, mara siya katubitang case 2 sa homogeneous linear ODE. Repeated roots, diba? Ang second expression nato kay na ay kapakapin nga x, diba? So, the same gyapon dere nga kay what if magbalik to nga kuan, magbalik ang expression nag-exist siya sa y of h and nag-exist pud siya sa y of p. So, ang isa ato, no, isa sa mga expressions sa ato dapat na i-partner nga x to the power of m. So, unsa nga erase na to to what power? M is the smallest positive integer such that the product of x of m with the solution has no terms in common na with y of h. Okay? So, if this seems worthy now, I think natay specific example para makita nato unsay ibot pasabot aning pag-modify sa solution. Okay, so don't worry lang. So what if our phi of x is not one of those three predetermined solutions, functions of x's? Okay, so let's say for example na atay linear non-homogeneous ODE that would be equal to a rational function or a logarithmic function. No? If the linear non-homogeneous ODE does not have constant coefficients also, then the ODE cannot be solved using method of undetermined coefficients. So we have another solution for that na itong ginatawag og method of variation of parameters which will be covered next meeting. So the MUC, method of undetermined coefficients, will only be used if number 1, constant coefficients, and if number 2, the assumed solution could only be either those three or combinations of those three assumed solutions.